Hello, Matrix of 2024 and every other year, grade 11th also. This is a very vital video for you as we prepare to write our maths metric November 2024. Great. So I've got a few questions I'm going to look at, almost a full paper. What you need to do if you don't have the paper is to pause the screen before we start solving, answer the questions and then play to mark. This is Bishop here, the CEO of Crazy Physics, and we would like to wish you all the best. But join us as we run through this whole session. I'm going to move quite fast, so your job is to make sure you catch up, rewind if you need to rewind, and make sure you understand the concepts that will be discussed in this paper. I'll start from 1.1.1. So I believe you have paused the video and you have done your work. Okay, 1.1.1. It says solve, stating any restriction. Okay, so if I look at the equation is like this. Now, natural mathematics instinct would tell me to expand that. And since I am solving for x, we bring anything x to the left-hand side. All right? And this is 2p minus p, because the p goes from the left to the right. So what do I have? What's common? X. And this is what? 2 minus p, and this would give me p. So what is x? P over 2 minus p. But stating any restriction, x becomes valid if p is not equal to 2. Why? If p is equal to 2, that gives me an undefined value of x. That's what the examiner says, state restriction. 1.1.2. Make sure you rewind and check again and look for errors, that we may be making together, and let's fix it. All right. What do I have on this one? X to the power negative 1 minus x to the power that equals to 20. The first thing I'm going to do, guys, this is a trinomial, and I'll show you why it is a trinomial. All right, check this. Minus 20. Okay, somebody says, how do I know it's a trinomial? Ax squared plus bx plus c. Watch this. If you take this exponent, the highest one, and divide it by 2, and you get the exponent of the second one, which is 1, it gives you a trinomial. 2 divided by 2 would give me 1. Automatically, I know it's a trinomial. Look at this one. Negative 1 divided by 2 would give me what? Negative half. Done. So if I want to make it very easy for you, I'll say let k be equal to x to the power negative half. And I'll show you something here so that everyone can see what's going on. My x to the power negative 1 can be written as x to the power negative half all squared, if you understand the laws of exponents. Half times 2 would give me 1. That is it there. Oh, okay. Minus x to the power negative half minus 20 equals to 0. So I'm already done. We said k squared. If you want to use k, minus k minus 20. Oh, what do you notice? I see a 4 and a 5. All right. And x plus 4. So x equals to 5, or x equals to what? Negative, no, not x. It's not x we're working with. We're actually working with k. All right. But the question did not say solve for k. It says solve for x. So what do? We bring back our x. What is x again? X to the power negative half equals to what? 5. What do I do here? I am going to multiply by the reciprocal. All right. I'll say times negative 2 over 1. And whatever I do on the left, I must also do on the right. That gives me 1. And this would give me 1 over 25. Okay. Or, what's our next one? X to the power negative half, all right, equals to what? Negative 4. There is no solution here. And I'm going to prove it to you. Why is there no solution? I'd like us to know one rule of maths. A, or let's say x to the power of a, will always be greater than 0 as long as x is greater than 0. If the denominator is greater than 0, then your answer should always be positive. Somebody says no, but it's a lie. Let's quickly prove that. I'm going to prove that here quickly and work something out for you. So a learner would have said, what if I do the same thing that I did on the other one? Okay, let me use a white for visibility. A learner says, okay, let's multiply this by -2, and then you have -4 by -2. Check. X would be equal to what? 1/16. And that is not true. Let's put that in a calculator. 1/16. And I'll test the other one for you. So if I'm saying X is X is 16, not 1/16. X is -4 squared, 16. No, it's fine. It's 1/16. 1/16. Because of the negative. Okay, cool. 1/16. If you are not sure, please, in tomorrow's exam or in any exam you are not sure of anything, please use a calculator now. So what is 1/16? 1/16, just to be able to prove that mathematical rule that I told you, to the power of -half. Check what that would give me. That would give me a 4. You see, not a -4. I hope that makes sense. All right. If I check 1/25, 1/25, that would give me a 5. So it must be positive when the base is a number greater than 0. I hope you learned that principle quickly. All right, awesome. We move. Again, what do? Pause and answer. Okay, I'm going to run here now quickly. I'm sure you are done. X plus 3, 2 minus x. Please make sure it's written in standard form by doing a sign change here. So make notes and learn the principles. When I say standard form, make sure your bracket starts with a positive x. So I have interchanged, and what I have simply done is to multiply that bracket only by negative. And when I multiply that by negative, my inequality sign changes. Oh, great. What do I do from here? I draw my number line quickly and I get my critical values. My critical values, x, okay, in case you don't know how we get critical values, we say -3, and the other one, you don't show this, just know it. Smaller number on the left, bigger number on the right. Once I have this in standard form, look at what my signs would be. Plus, negative, plus. Now, when I say something is greater than 0, what am I looking for? Positive values. Oh, so those are my positive. Check my inequalities. You see, that arrow is going that way. X is less than -3, or x is greater than 2. Please do not combine when we are dealing with positives. We are dealing with positive values. Please, greater than 0. Do not combine. Some of us just want to combine. If this question was like this, check this, greater than 0, then I'll still do the same thing, right? X minus 2, now less than 0. Critical values would therefore be what? -3, 2, plus, negative, plus. Less than 0 means I am referring to negative. And where's your negative? It is between. All right, that's the crazy physics system there. Negative, check, between. So inequality, this is when you combine, when you are dealing with a negative. All right, less than 0. I'm done there. I hope that makes sense. Oh, 6 to the power, how many? 1, 2, 3, 4, 5, 6. 6 of them. All right, number 1.1.4. Since there are 6 of them, you can see the question. I'm just going to say 6 into 6 to the power of x equals to 6 to the power of 6x. It's like saying, guys, k plus k plus k plus k plus k. That gives me 6k. Now, laws of exponent. This is 6 to the power 1. 6 to the power 1 plus x is equal to 6 to the power 6x. Same base on both sides, we equate the exponent. 1 plus x equals to what? Oh, 1 equals to 6x minus x. What do you have? 1 equals to 5x. Therefore, x is equal to 1 over 5. All right, we're done. We're moving as quickly as possible. Make sure you pause the question pages and do the questions before we do them. Solve simultaneously for x and y. Interesting. I know what's scary is the second one. Let's try to interpret the second one first. K equals to 3 and 4. Remember, the sigma means what? Sum. Okay, what do? We start by substituting what? 3 for k. So anywhere I see k, I'm going to write 3 minus 2 squared plus sigma means plus. Make sense? Okay, then my x still remains, but now my k is what? 4 minus 2 squared, and this should be equal to 5y. Don't forget, when I see sigma, it means sum. Let's solve. 3 minus 2, 1 squared, that will give me x. 4 minus 2 is 2 squared, that will give me 4x. Can you see? The examiner is just trying to check. Do you know maths principles? Oh, x therefore is equal to y. Beautiful. Can I then go to my other equation? 3y equals to 1 plus, anywhere I see x, I can write y. Ah, sweet, sweet maths. What do we have? 0 equals to y squared plus y, all right, plus 1 minus 3y. So what do we have? Y squared. What is y minus 3y? Minus 2y plus 1. Beautiful. Okay, so let's write it nicely. Conventionally, put in the 0. I'm just switching both sides quickly. What do I have? Y minus 1, y minus 1. Beautiful. Okay, because that will give me positive and negative 2's. Lovely. So y equals to 1 twice. And we already said x is equal to y. Beautiful. Therefore, x is also equal to 1 twice. Lovely. Because we are saying we have 2 equal answers there. Are we okay? Awesome. All right. Next question. Let's read that question. Let's read that question. Okay, 2 is a root. Please understand what the word root means. It means that if I sub x as 2, my answer must be equal to what? 0. Straight. 2 squared minus 3. We are told to find the value of what? P and the other root. So let's expand. 2 would give us what? 8 minus 6 minus p. So this examiner is checking, do we understand the meaning of roots? All right, so what is the value of p? P is 2. So 2x squared minus 3x minus 2. And now we are supposed to factorize and solve that. Factorize and solve that. Okay. There are so many ways of factorizing. You can use your quadratic, blah, blah, blah. I like to use something very, very unique. What I'll do is I'll multiply my 2 and the 2 there. So x squared minus 3x. So how did you get the 4? I took this 2 and I multiplied with that 2. Okay, now I can factorize this quickly. X, I know it's 4 and 1 minus and plus. But I multiplied with 2. I am now going to divide by 2. Guys, I'm doing this on the outside, okay? X minus 2. Now, the thing is, I don't want this constant value to be a fraction. I want it to be a whole number. I'm going to bring that 2 there. You can try this. It's quite nice. Those who have been following our channel know that that's what we do. 2x plus 1. Can you see what I did? I now transfer my solution back there. All right. So 2x plus 1 equals to 0, or, and x equals to what? 2. Or, what do we have here? X equals to negative half. Done. That's the other root of the equation. That's the other root of the equation. Good. Question number 2. A geometric sequence, you got to read, and an arithmetic sequence have the same first term. Okay, let's do this. Arithmetic and geo. T1 is the same as T1. The common ratio of the geometric sequence is 1/3. The common difference of the arithmetic is 3. The sum of 22 terms of the arithmetic is 734. Hold on. Sum of this arithmetic is 734 more than. More than means plus, above. Sum to what? Infinity of the geometric. Guys, you've got to learn to interpret. Don't rush it. Statement by statement. What are we looking for? We're looking for T1. Okay, the first thing I'm going to ask ourselves is, how do I get the sum of arithmetic? N over 2, 2a plus n minus 1, what? D. We are told that this, okay, S22 will be 22 over 2, okay? We don't know A, but we know N as 22. So 22 minus 1. Oh, lovely, we have a difference. Guys, you notice that I have actually put out everything. They said S22 is equal to 734 plus sum to infinity. Okay, so this is my S22. Let me remove this. Or let's leave it just for clarity. All right. Plus or is equal to more than sum to infinity a over 1 minus r. Oh, by the way, let me put this one here and substitute here. What's my a? We do not know a still, but 1 minus 1/3. The rest is just mathematics now. What do we have here? 11, 2a, that would give us 21. 21 times 3 would give us what? 63. Okay, I'm going to remove this equal sign. And that is 734 plus a over 1 minus that will give us what? 2/3. We're going to try to simplify this. Let's expand the bracket to make it easy for everyone. 22a, 63 times 11 would be 6. 3, 6 plus 3 would give us 9. Okay, and that would give us 734 plus. Now, if you don't know how to deal with fractions, it is like this. And then you change it. So that gives us what? 3a over 2. Let's bring all the variables to one side. 22a minus, it's not 39, please write nicely in the exam. 734 minus 69 what? 3. Okay, so what is 22 minus 1.5? That will give us 20.5. Okay, if you are not sure, please guys, use a calculator. Oops. Use a calculator, please, please, please. Don't be a genius in the exam and get things wrong. What do we have? 22 minus 3/2. All right, 41/2. So that gives us 41/2a. And what is 734 minus 693? That would give us 1. 13 would give us what? 41 as well. Am I right? Let's just confirm. 734 minus 693. All right, 41. Okay, so what is a therefore? You can simply tell that a is 2. All right? So a is 41 times 2 divided by what? 41. You can just do basic maths there. A is 2. These questions are straightforward. Just make sure you read carefully and you work things out. Okay, let's look at this one. Beautiful question here. A certain quadratic pattern has the following pattern. T1 is P. Start creating the pattern. It's a P. They told you this one is P. This is what? 18. We don't know this. And T4 is what? 41, which is 4P. T3 minus T2 is 10. T3. Oh, so the difference here is 10. Beautiful. Automatically, I'm already seeing my T3 as 28. Okay, we are looking for the value of P. Okay, let's try to play around there. Already I see my T3 as what? 28. Interesting. Now, what do we know? We know that this one has to be 18 minus P. And this one has to be what? 4P minus 28. Then we move over to the second difference. 10 minus, please use brackets. Please use bracket. 4P minus 28. If you want to use bracket, use it here, minus 10. Let's simplify. 10 minus 18 plus P, which would give me minus 8. So P minus 8. And this would give me what? 4P minus 38. Or for everyone's sake. And what do we know? The second difference is the same. Oh, sweet maths. So P minus 8 equals to 4P. So P minus 4P minus 38 plus 8. What do we have? Minus 3P minus 30. So what is P? 10. Beautiful, beautiful question. We move quickly. What is this? Evaluate the following series. Okay, let's first study. 1 plus sine squared 2 plus 3 plus sine squared 4 plus 5, okay, plus sine squared 6. I see that it's a sum of two patterns. I have 1 plus 3 plus 5 plus, and the examiner told me plus 85. Do you notice that? And then we have what? Sine squared 2. So the even ones are trigs. It's maths. Somebody saying, but this is paper 1. No, it is maths. Okay, how do we navigate? Let's look at the first one. Let's call this series A, and let's call this series B. The question I'm going to ask you is, it's a sum, all right? It is a sum. Sn equals to what? N over 2. I hope you know this formula. The first and the last term. But here's my worry. How do I know the number of terms? I've got to go back to my grade 8 by creating my Tn. all right. What's my difference? My difference is what? Okay, let me show you something. I hope everyone will be able to do this. It is 1, 3, 5. That's 2 there, confirmed. Oh, so Tn, put in a minus here. Drop this 2, put the n. What is 1 minus 2? -1. Oh, sweet. That's my Tn. Now, 87 equals to 2n minus 1. 88 equals to 2n, which gives me n as 44. Oh, sweet. So now I know that there are 44 terms. Beautiful. Oh, by the way, this one is also 44 terms. Because I see that it's 1 and a trig, number and a trig, number and a trig, number and a trig, and it ends with number and a trig. So it's a pair which is complete. So if there are 44 constants, there will be 44 trigs as well. You've got to look at that. All right, let's look at the constants. Let's look at sum of the constants. What are we going to call the sum of the constants? S44. We said there are 44 terms. All right. What's our first one? 1. And what's the last one? 87. Great. What will this give us? 44 squared. Okay, let's just put it in a calculator. 44 divided by 2 give us 22. 22 times 88. 1936. What do I then do to the sine squared? Okay, beautiful. Check this. Sine squared 2 plus sine squared 4. All right, watch this. Sine squared 6. This is an even number of terms. If I were to continue, I want to do something for you. I hope you remember your co-functions that what? Sine 88 is the same as cos 2. Why? These are complementary. When I add them, I'm going to get 90. Oh. Check now. Which means I can change my sine squared 88. I want to do something for you. Sine squared 88 can be written as what? Cos squared 2. Oh, beautiful. What about the next one? 86 would be what? Cos squared 4, because 86 plus 4. Oh, what about 6? 6 would be cos squared what? 6. Now, do you notice this plus this? Sine squared plus cos squared will give me 1. Another one. Another one. All of these are equal to 1, 1, 1. So there are 44 numbers, but if we start pairing them together, we are going to have 22 pairs. Does that make sense? So this whole thing will be equal to what? 22. There are 44 terms, but each pair gives me 1. And this is how you present your answer. So final answer now will be equal to what? 1936 for the constants, 22 for the trig. 6 plus 2 is 8, 3 plus 2 is 5, and you have 1958. So sine squared A, this is the secret, plus cos squared A would be equal to what? 1. So there are 44, but 22 pairs. That gives me 22 as my answer. I hope that makes sense. Please rewind, listen over and over again. Ask your teacher for help if you need help in understanding this. All right. The diagram alongside represents a frog making a series of jumps. With every next jump, he has only enough energy to jump to third the distance of the previous. Okay. If the first jump is 81, calculate the length of the second jump. Remember, the next jump is 2/3 off. Off means multiplication, so 3.1. Second jump, T2, will be 81 times 2 over 3, and that will be 54. Because 81 divided by 3 is 27, multiplied by 2, 54. Determine the length of his ninth jump. Now, since it's you can see it's a ratio because I'm multiplying. We can simply get our Tn. A r to the power n minus 1. So Tn, what is our A? 81, 2 over 3. Sweet. So what is T9? What are we looking for? 81, 2 over 3, 9 minus 1, which would give us 8. Let's use a calculator quickly to get an answer. So it's a geometric, 81, 2 over 3 to the power of 8. What is our answer? All right, 256 over 81. 3.3. If he continues to jump in this way, continues, will he be able to catch a trapped insect that is 230 centimeters away from his starting point? Show all your calculations. He continues to jump. The question is, how far can he jump? What is the infinite jump or distance? Sum to infinity. A over 1 minus r. What's our A? Our A is 81, the first term. 1 minus 2 over 3. If this is greater than 230, then yes, that is where his energy would finish. 1 minus 2. It's important to interpret. 243. Oh, this guy is going to catch the insect. 243. So, answer, will he be able to catch the trap insect? Yes. Since his total distance is 243 and the insect is just 230. I hope that makes sense. If he continues, talks about indefinite jump until he stops. Okay, we move on to question number 4. All right, we're moving quickly. We are on question 4. In the diagram below, the graph of a hyperbolic function f of x equals to x plus k over x plus p, where k is a constant, is drawn. A, 1 and 0, and b are the x-intercept and the y-intercept of f respectively. The vertical asymptote goes through x-axis at x equals to 3. Beautiful. This is important. Already, I know my value of p. Now check. Write down the value of p. Please be careful here. Anytime you talk about x's, x's are deceiving. That's what we say. So the sign of x will always change. If you are not sure, I'm going to show you what to do. We're saying x plus p should be equal to 0. X is equal to what? Negative p. But what is x here? But x is 3. If you are not sure, this is the way to work it out. For those of us that know, we just write our answer, right? So 3 equals to negative p. What is p? If you know your maths, you don't need to write all of this. You just write it down. X's are deceiving, so the sign will change. Determine the value of k. All I need to do, number 2, y equals to x plus k over x minus 3. Is there a point where we know on the graph? Yes. 1 and 0. 1 and 0. My x is 1 and my y value is 0. 0 equals to, what is my x value? 1 plus k. Functions is all about substitution. Alright? So you can, if you want to cross multiply, you're welcome. 1 plus k will be equal to 0. K will be equal to what? Negative 1. We're done. Number 3. Calculate the coordinate of b. What do you know about b? What can you see? B is my what? Y intercept. Therefore, I know my x is 0. So I have y equals to, my equation is now x minus 1 over what? X minus 3. So what's our answer? Please show your 0 substitution, which would give me 1 over 3. They said coordinates. Please write it. Obey the instruction. X is 0. Y is 1 over 3. Alright? 1 over 3. We're done with that. Let's move on to the next question. Let's move on. Okay. Determine the values of x. A lot of learners don't know how to interpret this. 4.1.4. X multiplied by f of x is less than or equal to 0. Now let's interpret. Start interpreting from the right hand side. Less than or equal to 0. Okay, negative there. Is it fine? I have to multiply two things to get a negative. It means if this one is positive, this one has to be a negative. Or if this one is negative, this must be a positive. Why am I writing times? Positive. Now they also said it must be equal to 0. I need to look for where x is 0, also where this one is 0. And by the way, f of x refers to y of the function. So I'm saying x times y. That is what I am looking for. All right. Now, let's quickly walk through. Let's walk through. Let's go to the graph. Let's go look at x and f of x. It's very easy. Take your pencil and write it. X here is negative, but x here is 0. X here now is positive across like that. What about f of y? F of x rather. This one is above the x-axis, so it is all what? Positive. What about this one? It is below negative the x, okay? At that point, it is a 0, and then that's why I'm using different colors. You can also use a pencil and a pen for clarity. What are we looking for, my beautiful learners? We are looking for where they are of opposite signs. So this is what we do. Take a ruler and just move the ruler. What am I touching? Positive and negative. That's what I need. That is what I need. Continuous up to that point. After that point, both of them becomes positive. I don't need that point. So this is what I am looking for. I'm looking for where they are both positive and negative, and there's a 0. Let's continue. Do you notice positive and positive? But wait, the blue one, at that point we have a 0. Great. Then the blue one starts changing to negative. Oh, positive and negative. There's nothing on the asymptote. And after the asymptote, they are both what? Positive. I am looking for where they are both positive and negative. Do you see that? Alright, so from 0, what do we say? From 0, moving to the left, okay? And, okay, so x is less than 0, left. And then between what? Between 1 and 3. Once I say between, you know what my inequality should be. So let's write our answer, 4.1.4. X is less than 0, and x between 1 and 3, but equal to 1. Y equal to 1. At 1, I have a 0. So please mark it off. Write the 0 points on the graph. They are very important. 4.1.5. Quite from experience, quite a number of learners don't know how to do this. There are 2 ways. I'm going to quickly try to show you both ways. Our f of x is x minus 1 over what? X minus 3. I'll use the K method, and then I'll use long division. This is what I will do. X minus 1 over x minus 3. I'm going to do this. Anywhere I see x, I am going to replace it with the denominator. So instead of writing x, I'll write x minus 3, check, plus k over x minus 3. So I'm saying the denominators are the same, the numerators must also be the same. So let's solve for k, just algebraically. X minus 3 plus k. Do you notice the x would cancel each other? And if I move this over here, positive 3, so k becomes what? 2. Then I can rewrite my equation as this. X minus 3, my k is now 2 over x minus 3. And I can do this algebraically by splitting it. So x minus 3 over x minus 3 would give me 1. Oh. So my equation can then be written as 2 over x minus 3 plus 1. Or long division. Look at this. I'm going to squeeze it here. X minus 3 will be outside. I want you to follow the step. I'm going to ask myself this question. Check this. X divided by x. That's positive 1. I'm going to put the 1 here. I am now going to use the 1 to multiply everything. What is 1 times x? X. 1 times negative 3, negative 3. Long division, what do we do if you remember? We subtract. X minus x is 0. Minus 1 minus minus 3 would give me a positive what? 2. Now in grade 8, we used to call this the remainder, or grade 7. We used to call this the quotient, and we used to call this the divisor. Alright. F of x can be written as the remainder over the divisor plus the quotient. What is my remainder? 2. What's my divisor? X minus 3. What's the quotient? Plus 1. Both ways give you the same answer. You need to just practice this. You have enough time to get to know how to work that out. 4.2. 0.2. Okay guys, quickly on 4.1.4, there's an omission here that we need to quickly fix. This must be x is less than or equal to 0, because the examiner says we want less than or equal to 0. Please take note of that omission, and so that you are confident about your answer. Awesome, great. Okay, you and I need to know how to interpret these properties. I'm going to guide you. Okay, the examiner says the domain x is an element of real numbers. X cannot be equal to -2. Already, they have given me my vertical asymptote. X equals to -2. Y equals to x plus 6 is the axis of symmetry. Please take note. The axis of symmetry passes through the point of intersection of the asymptotes. That is very, very important. So I know my x value already. -2 plus 6. What is y? 4. So I already have my asymptote. The function is increasing for all x values. When they say a function is increasing, guys, it must be like this. All right? For all, function is increasing for all x is an element of real number, but x is not equal to -2. Draw a neat sketch. Okay, so the question is, I'm going to show you if you are doubting a few things. First, I'm sketching a hyperbola. I need to first fix my what? Asymptote. X equals to -2. Please write that there. Right? That is important. They said sketch and include all the asymptotes. And what is my y value? 4. Okay. Please, if you are not sure, follow the instruction. The examiner says it is increasing. If it is increasing, it actually means your A is negative. But if you are not sure what I just said, check this. If I draw a graph like this, increasing. If I draw it like this, decreasing. It cannot be here. Increasing. And then what? Beautiful. It is increasing and increasing. We do not have a value for A, so we're just going to sketch a little graph. Increasing. There we go. Now, here we're not so exactly sure, but examiner just wants to see that because we do not know the value of A. And that's your graph there. I hope that makes sense. Examiner is interested in the shape of the graph, and that is it, of this function. My x plus 6, if I wanted to draw that, would be this. My x plus 6, let me see if this one will be clear. It's a positive gradient, so that will be my x plus 6 if I want to show that, because that therefore will be what? 6. Axis of symmetry. All right, good, 14 marks there. It's the concept and the principle that we want to get, and that's why I said that the axis of symmetry, check, passes through the point of intersection. So I know that coordinate as -2 and 4. The graph of f of x is equal to ax squared plus bx plus c and g of x. All right, let's trace. That's my parabola and a straight line I sketched. The graph of f intersects the x-axis at p. Okay, -5 and 0. It's not there. You know what I would do to make it clear? I'm just quickly going to write that -5 there. And t, 1 and -1. Okay, I almost screamed there, -1. Y-axis w, 0 and 5. Sweet. The two graphs intersect at q and p. Come on, procedure. R and S are points on f and g respectively, such that SR is perpendicular. This tells me it is a vertical distance. Another way of letting you know that is to tell you that it is parallel to the y. So it is perpendicular to the x and also parallel to the y. Watch out for language there. Show that f of x, oh sweet, sweet, sweet. We are looking for the equation. Number one, how do you get the equation of a parabola? A, x minus x1, x minus x2. X and y are points on the graph. Any point that we know. I know point W. So y is 5. X is 0. 0 and 5. Minus. Now, what is x1? x1 is negative 5. If I throw it in here, it becomes negative, negative. That makes sense? And then my x is still 0. My x2, let me write it here for you guys. x1 is negative 5. x2 is what? Negative 1. All I'm doing is I'm throwing it. Negative, negative. That gives me that. Okay. Let's x. What we have? 0 plus. Okay. 0 plus 1. 1. So a equals to 5. No, 5 equals to. Let's do it. 5 equals to 5a. Therefore, a equals to 1. I can therefore substitute. There's another way of getting this, but let's just go the simple way. Y equals to, I have 1. X plus 5. I replace all of that and x plus 1. But I leave my x and y. Expand x times x. X squared plus x plus 5x plus 1. Check. X squared plus 6x plus 1. 3 important marks. Calculate the coordinate of Q. What do you notice? It's a point of intersection. What do? We equate the two functions. So f of x equals to what? G of x. Come, let's work it out. Now we know our f of x, which I can pick from 5.1. X squared plus, sorry, why am I saying plus 1 here? 5 times 1 is 5. Sorry. Okay, plus 6x plus 5. What is our g of x? 2x plus 10. Let's quickly work it out. If I move the 2x over, it will become a negative. 6x minus 2x will give me what? 4x. 5 minus 10 would give me negative 5. What do we do now? I'm just going to squeeze it here, factorize. Guys, if you are not sure factorizing, please use the quadratic but show your substitution. All right, positive 5 minus 1. So x equals to negative 5 and or x equals to 1. I already see that's my p. Oh, so I'm looking for, so this is the one I am working with, q. Read the question before you move on. Coordinate, which means I must get the y value. Just sub in into the simple equation g of x. All right, 2 into 1 plus 10. And that will give you what? 12. So what is q? 1, 12. Make sure you write it as a coordinate. Very important if the examiner is asking you for coordinate. You can pause, rewind, and rewatch. Oh yeah, calculate the coordinate of q, done. Show that f of x is not equal to negative 5. Ooh, for all values of x. Somebody saying, how do I do that? Please, my dear learners, look at your graph. F of x is y value. Show that y is not equal to negative 5. If I look at my graph, all of these are y values. Where does it stop? Oh, it stops right here. Examiner is clever. All the examiner is asking for is to find the minimum. What is the minimum value of y? What do? Minimum is at the turning point. So let's find xtp minus b over what? 2a minus, what is our b? Positive 6 over 2, 1, negative 3. So what do? We find the ytp by throwing it back into the original. X squared plus 6x plus 5 we must get a number bigger than negative 5. All right, negative 3 squared. Please make sure you type it the way you have written it. Some of you leave the negative outside and it will give you a problem. Negative 4. Oh, so the minimum is negative 4. Can you see? So my range, y is greater than or equal to negative 4. Y cannot be equal to negative 5. We are done there. What's next? That is 5.3. 5.3. Done. Now 5.4. Consider point R where SR is the maximum. Alright, maximum distance. Determine the gradient of the tangent. Guys, okay, I'm just going to go the conventional way here. Gradient f prime of x is equal to m. That's the conventional way. So I know my f of x as what? X squared plus 6x plus 5. Okay, what is my, let's derive. But here's the problem. I'm looking for the gradient, and I know that if I can get the value of x, then I can get my gradient. Oh wait, but they said SR. We said vertical distance, my beautiful learners, is always top function minus bottom function. Don't forget that. Let's go back to the graph. Which function is on top? Let's go back to the graph quickly. At SR. It is the straight line. G is on top. F of x is at the bottom. So basically the examiner is saying g of x minus f of x. 2x plus 10. Please use a bracket and write what you are doing so that you see clearly. What do you have? 2x plus 10 minus x squared. Don't do shortcuts, okay? What do you have? Negative x squared. What is 2x minus 6x? Negative 4x. 10 minus 5. Now, that is the vertical distance. But the examiner said maximum vertical. Oh, it's a maximum. What do? We find the x value of that maximum, all right, x max, or vertical distance, by saying minus b over 2a, or you derive and equal to 0. Minus, what's our b? Negative 4 over 2 negative 1, which is what? At negative 2. Sweet. F prime of x is equal to m. So what is f prime of 2, which is equal to m? We go back and substitute our 2 there. What do we have? 6 minus 4, and the answer is 2. So just follow the language. Note the principle per language. That's what I'm going to say. Principles per language. 5.4.2, the equation of the tangent. All right. 5.4.2, equation of a tangent. Y equals to what? Mx plus c. Already I know my x is negative 2. Okay. At that point, right? Yep. And m is 2. The question would be, what is y? Let's go back. Equation of f to f at r. Okay, so we do not know the y value there, but how do we get the y value at any point? We sub back into the original equation. That's how we get the y. All right, it's x squared, so it's negative 2 squared plus 6x plus 5. Let me hope that I got that equation right. X squared plus 6x plus 5. Beautiful. What will this give us? That will give us 4 plus 5, 9 minus 12. That's negative 3. Okay. Now I know my xm. Great. Y equals to mx plus c. What is my y value? Negative 3. What is my m? 2. What is my x? Negative 2 plus c. What is c? Negative 4 on the right. Move it. Becomes positive 4 minus 3. 1. Alright. Let me see something there. Okay. Makes sense according to the graph. So what's my equation? Y equals to 2x plus 1. 5.5. Consider x greater than x value of p there. For which values of x will g of x minus the inverse? Wait, what is g of x? It's 2x plus 10. Alright, I would want to just do this algebraically and run away. Y equals to 2x plus 10. Let's inverse it. What does it mean? Anywhere I see y, I'm going to write x, and anywhere I see x, I'm going to write what? Y. So x minus 10, because your equation must always be written as y equals to. So what did I do there? I divided everything by 2. So this is my g inverse. Okay, we could also do it graphically, but I think this in this case would just be a bit easier. G of x minus its inverse greater than 15. What is my g again? 2x plus 10 minus x over 2 minus 5. Please, the bracket can cost you a lot of marks. Minus x over 2 plus 10. Negative times negative will give us what? Positive. Oh, sweet maths. Now, 2x, please understand what this means. This is 2 minus half. Alright? And that is 1.5, which is what? 3 over 2. If you are not sure, please use a calculator. Is that okay? So x should be greater than 0. Because if I divide both sides by 3 over 2, I hope you know how I got my 0. 10 plus 5 is 15. Move it over to the other side. Okay, but let's check something. They said x is greater than the x value of p. Okay, we're good. We're good. Because that's negative 5 there. Awesome. That question is done. So learn to interpret correctly and life becomes quite easy. Look at this one. In the diagram, the graph of f of x is log base ax are drawn. Graph G is the reflection of f in the line y equals to x. Guys, anytime you see the line y equals to x, the examiner is talking about inverse. That's your line. Y equals to x. It means the examiner is referring to what? The inverse function. Okay. Graph f passes through the point P, 4 and 2. Q is the x-intercept. Please make sense of the question on the diagram. Now, write down the coordinate of the image of P, P prime, the image of P. All right. Look, we are reflecting this graph along the line y equals to x. It means anywhere we see x, we make it y. We are done already with 6.1. It's just a language. It is now 2. Okay, P, the image, x becomes y, and y becomes x. Inverse. 6.2. Show that a equals to 2. It's all about substitution. It's all about substitution. Just substitute. What do we know? Y equals to log base a and x. I'm working with f, guys. Don't make a mistake. And p is on f. So what's my y value there? 2. Log base a, and my x is what? 4. Remember, this one comes here. It's a base. It will remain as a base. Lovely. What do? We can write both of them as the same base. Therefore, a equals to what? 2. And if you look for the square root as well, a would be what? Plus or minus 2. But this is an increasing function, just like where we came. Therefore, a equals to 2. Write down the equation of G, 6.3, which is the inverse. Y equals to log, now I know my base as that. Let's find, we can inverse from here two ways. X equals to what? Log base 2 y. Now what do we say? We repeat the same process. The base comes here and remains a base. And we are left with y. Therefore, y equals to, so the base will remain as the base. With that, 6.4. Let me reproduce this. And we have a fresh page for 6.4. T is a point on F in the first quadrant where TR is parallel to the x-axis. Let's try to make sense of the whole thing. TR is parallel, so let's draw that. Okay, we're not sure, we're just, drawing a graph. TR is parallel to that. Calculate the area of RT P'. All right, where is P'? P' is 2 and 4, so we're just going to try to create a diagram to make us see clearly. Somewhere there, 2 and 4, not drawn to scale. All right, not drawn to scale, so we have P' there. So I might need to chop and change here and there, but let's see something. We have a triangle, and this is the triangle we are looking for. Now, what we need to do is to be able to find the respective points. Don't mind the diagram is not drawn to scale. All right, but one thing I know is this. What is the coordinate of R? Remember my G inverse is what? Y equals to 2 to the power of x. And R, which is my y-intercept, x equals to 0. Oh, so y value is 1. And since they told me that it is parallel, I can therefore get the coordinate of t. Okay, this is not drawn to scale. T and P are not on the same place. Okay, so let me try to make, let's say it's even there. We're not sure where it is, all right, but we know it's somewhere. Okay, this graph is not drawn to scale, so don't make assumptions. So let's say T is somewhere there, or even just to make it clear so that Elena doesn't just make assumptions. All right, let's draw something there. We don't know where T is, we're looking for it. But because this line is parallel to this line, I already know my y value. And that is on the f of x. What is f of x, by the way? It is log base 2. I know my y value as 1. I'm looking for my x. Okay, not my x. I don't need them. 2 to the power 1 equals to, oh, smart. X equals to 2. So the coordinate of t is x equals to 2 and 1. Wait. What is the coordinate of the P' image? It's 2 and 4. Oh, that point when it comes down, x is also, do you notice? Let's draw. This graph is not doing justice, not drawn to scale. But if I have my P value, okay, I'm just going to try to, since I have now seen what we are looking for, let's make it make sense to everyone. Basically, we're saying x is 4 here, not drawn to scale, remember? So halfway there should be somewhere where, not drawn to scale again, be mindful, that, okay? And we are told TR is parallel, so just going to do that, okay? But you understand what I mean? I think this graph should have come down, all right? R, this graph should have come down, and then we have that. What do you notice? This is x is 2, y is 1, 2, and 4. It's actually a straight line, which gives me what? A right angle triangle. So area of triangle RT, the image of P, have base times height. What is the base? This becomes my base, which is 2. And the height is here, 4 minus 1, 3. Okay, and my answer is 3 units squared. Makes sense. Diagrams are not drawn to scale. Oh, money, money, money. Finance. We're moving quickly. Determine the nominal interest rate if an investment received R% per annum compounded monthly, whereas effectively it receives 8,3. So I need my effective formula interest. And somebody says, I usually forget this formula. Please take note. Look at it. This is not my effective formula. Just want to show you where to get it from. You look at your F formula. The bracket on top there, that is your I effective. This is I what? So just write that down. I effective equals to what? 1 plus I. That will be nominal over the frequency. Determine the nominal. If the effective interest is 8,3%, beautiful. So 8,3% equals to 1 plus I nominal compounded what? Monthly. And this is always done 1 year. So that it's just met now. Let's move the 1 over. What are we going to have? 1 plus 8,3%. All right. 1 plus I num over 12. Guys, can I just find the square root, the 12th root of that quickly? All right. By looking for the 12th root. Okay, I don't want to confuse anyone here. I have that. That's what I have. How do I get rid of the 12th, power 12? I find the 12th root of both sides. So, guys, I want to use my calculator once. Once I do that, it opens the bracket for me. I num over what? 12. I'm going to bring this here, which will be -1. So watch. Oh, 12th root. So I'm going to grab my calculator. I know I'm looking for the 12th root. I try to do almost everything manually and get to my calculator. What do I have? 1 plus 8,3%. Okay. Now bring the 1 over, -1. You see that, right? Now the 12 is the denominator, which I'm going to cross multiply times 12. Good. Check this. The examiners want you to write at least 6 figures. And that is what? 0,08, 1, 2, 3, 4. All right. I num 1, 2, 3, 4, 5. It continues. Multiplied by what? 100. And what would that be? No, 0,08. All right. And that gives me 8 what? %. That is my nominal what? Interest. Beautiful. Martin takes a loan of 400,000. Let's create a fresh page for ourselves to deal with 7.2. Please, I hope you remember that F formula. It actually helps you to get your effective interest. Don't forget the percentage. That is of extreme importance. Okay. All right, now if I look at a 7.2, Martin takes a loan of 400,000 at an interest rate of 11% per annum compounded monthly. Martin must amortize, which is to pay off the loan within 5 years, with equal monthly repayment starting in 1 month's time, which is normal. If he pays the loan over 5 years, his calculation gives him the monthly payment of 8,696.97. Now, how many full monthly repayments would Martin pay if he were to increase the monthly payments by 303? Okay, wait, hold on. So his old payment would be what? 8,696, what? 97. But this guy is deciding to add 303, that. What will that give us? That will give us a 0. That will give us a 0. And that will give us a 0. That will give us a 0. That will give us 8,900. Let's just take a calculator and do a confirmation quickly. 8696,97 plus 303,03. All right. Oh, that gives us 9,000. What am I doing? 9,000. All right. That gives us exactly 9,000. All right. 9,000. My bad. Okay, now Martin takes a loan of 400,000 and at an interest rate of 11.2% compounded monthly. Martin must amortize the loan within 5 years with equal monthly. Now, already I know that talks about an X there. Okay, starting in 1 month's time, which is normal. If he pays the loan over 5 years, his calculation gave him a monthly repayment of what? 8,696.97. How many full monthly repayments would Martin pay if he were to increase the monthly payment by 303? Oh, so what are we doing? We're adding 303,03. What is going to be the new value? Quickly, let's get a calculator. 8696,97 plus 303,03. That will give us 9 grand. All right, so this guy is now paying 9,000. How many fools? So we are looking for n. Since we are paying back, p equals to 1 minus, all right, 1 plus I to the power of negative n. Oh, there's an x missing. Please use the formula page. P equals to x over I. Now, what do we have? How much are we paying back? We took a loan of 400 grand. 400,000. We're paying back 9,000. 1 minus 1 plus. What is our interest rate? 11% compounded monthly. Guys, don't change that. Don't say times 12n. You're creating problems. 11% over 12. Okay, I want to show you. I want to do this calculation once without using calculator so many times. I'll cross multiply or divide first. 400, 1, 2, 3 over 9,000 multiplied by, bring that interest over. Now what will this give you? 1 minus 1 plus 11% over 12. Now my brackets have already fallen off. Oh, which means I can bring that and it becomes negative 1, right? Watch this. Now, can we take the whole of this to the left-hand side? Because I want us to use our calculator once. When I come to the end of the board here, take it over to the left. It becomes 1 plus 11% over 12. You see, I don't want to keep writing all my decimals. I'm switching sides. That has gone to the left-hand side, becomes positive. What happens? Or you know what? Let's not move the 1. Let's not move the 1. Okay? So we take that over. Now, if we take this entire thing over there, what happens? It becomes 1 minus 400. Please, let's count the zeros. Over 90,000 times 11% over 2. I don't know if that makes sense. Now, definitely, I know I'm going to use my logs. Negative n would be what? The log of, what's my base? 11% over 12. Okay, now we need to fix that answer. What would I say? Get a calculator quickly and say 1 minus 400, 1, 2, 3, over 9,000. Let's be careful of the zeros. Times 11%, don't forget that, 12. Okay, that actually gives me a lovely answer, 16 over 27. Now, you write that there, fraction, even better. What is minus n? Get a calculator. So you are going to use your answer button. All right, for me, my answer just falls away. I always buy new calculators at every sum. I'm a rich guy. 11% over what? 12. close the bracket, and then I have 16 over 27. Check. Look, lovely. Okay, guys, I need all the decimals because I see that the next question is going to require me to calculate final payment. So I'm just going to write it down somewhere. 3, 4, 2, 8, 4, 1, 8, 7. All right, 3, 4, 2, 8, 4, 1, 8, 7. Okay, so what is my n? I'm getting negative 57, comma. I need the comma. 3, 4, 2, 8, 4, 1, 8, 7. Okay, and that gives me how many full payments? First, let's write 3, 4, 2, 8, 4, 1, 8, 7. But full payment would be what? 57 full payments. 57 full payments. Now, what is its final payment? Please know how to calculate final what? Payment. Very, very important. Know how to calculate final payment. Going to quickly take you through a 2-minute crash course on final payment. Final payment will be this. A would be equal to P 1 plus I to the power of 1, where this is the outstanding balance after all full payments are done. And to get that P, I'll say P equals to what? X 1 minus 1 plus I to the power of negative n over I. I'm looking for that amount, but I'm paying what? 9,000. 1 minus, it is 11% compounded monthly. Now, what is the outstanding? It is the decimal. That's why I had to write all that answer down. Close the bracket over what? 11% over 12. Throw that in a calculator. Once I throw that in, I'm going to now say that amount multiplied by 1 plus 11% over 12. And that would be my final payment. Question done. Quickly, let's get this sorted. What do we have? Okay, so I'm going to say 9 grand. All right. Please type it the way you have written it. So type nicely. Like I said, some of you write and you can't even read what you have written. Minus 0,3428 41. If you make a mistake here, it shows corruption. All right. 11% over 12. This is how much? All right. 3066, 70. If you want to get a perfect answer, because I'm not done, I will write the whole answer. Okay. So it's 3066 720 971. Then you take that answer and bring it right here, because that money must grow. 66,720. Let's shift this. So use your answer button on your own calculator. 971. And what will my answer be? Let's grab a calculator. Let's move this and put a calculator here. 3066, 720 971, open bracket, 1 plus 11% over 12. All right. 3094,83. Now we can round off to 2 decimal places. 3094,83. And that's it. Question done. Okay, let's go for the last one. The last one has to do with some personal accounting. Every time I see the word interest, then it is linked to the person's direct purse. Please take note of that. every time we see the word interest, it is linked to the person's direct purse. Let's see. How much interest will he save based on his decision in 7.2.1? Interesting. Now, interest is accrued over what a person pays. So Martin checks his diary and says, okay, if I decided to pay my old ex 8696.97 and he's paying that for 5 years, he would have paid how many every month? He would have paid times 60. That is what he would have paid from his own purse or wallet or account directly, okay, without interest. 8696.97. So guys, every time it comes to questions like this interest, take it up with the final what he's paying. What do we have? 521818.2. 521818. Okay, but with the new X, what did this guy pay? This guy was paying 9,000, but mind you, he paid it 57 times. Then he paid that extra last amount. We are looking at all the money he paid from his account. 3094.83. 3094.83. This is the money that he paid from his own purse. He paid 9,000 57 times, and then he added 3094.83. So in total, from his own purse, he paid 516,094.83 cents. 516,094.83. 516,094. Okay, so all we need to do is to subtract to get the interest that, or the money that he saved. 521,818.2 minus 516,094.83. All right, this guy saved a lot. 5723.37. 5723.37. This is how much he saved. All right, just check, make sure there are no mistakes, and that is finance. Awesome. Okay, question 8. Let's run quickly now to calculus. We are almost done with the entire thing. Determine f prime of 2. All right, f prime of 2 from first principle. We'll say, usually it's f prime of x. Not a problem. Let's walk through. Okay, I'm going to just get a blank page. Okay, f of x equals to what? -5. Now please don't change this. We need to find f of x plus h if I'm working with first principles. -5 over x plus h. And right now you should know what to do. Know the answer that you're supposed to get. All right, if I have this can be written as that, and if I differentiate, I know I should get what? -1 times -5 will give us 5. Just keep this at the back of your mind. All right. Now, f prime of x is equal to limit as h approaches 0, fx plus h minus f of x over h. Limit as h approaches 0. What is my f of x plus h? What is it? We replace it because we've done it outside, right? Makes sense. -5 over x plus h minus, what is f of x? Please, bracket. Please, 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 take your time. Now, limit as h approaches what? 0. Let's expand. Negative times negative would give us what? Positive. over h. Now there's what we call DDD. You multiply this diagonal first. Okay, so limit as h approaches 0. What is negative 5 times x? Negative 5x. That's the first diagonal, left to right. Then I'll multiply this diagonal as well. Alright, it is plus 5x plus h, so it's 5x plus 5h. And then I'll multiply my denominator, DDD, x squared plus x what? H. Remember, everything divided by what? H. So what do we have? F prime of x. We still write this. You'll be penalized if you don't write your limit. Alright, limit, and write it as close as possible to the function. Do you notice negative 5x plus 5x? Something must cancel, please. Something must cancel. So what are we left with? We're left with what? 5h. We're right? Yeah. We're left with 5h over what? X squared plus xh times 1 over h. That would go. What do we have? Limit as h approaches what? 0. What then do we have? Anything that has to do with that would go away. So this is my f prime of x. But then what is f prime of 2? Anywhere I see x, I am going to replace it with 2. And that is 5 over what? 4. 5 over 4. I hope that makes sense. 5 over 4. We're good. Okay, let's go to the next question as I'm racing to finish. Alright. We want, ooh, lovely. Lovely. Now we have f of x equals to x cubed minus 8 over 2 minus x. Quite a lot of learners have forgotten how to do that. F of x is what? X cubed minus 8 over what? Alright. Now, this is what we do. We must be able to expand difference of two cubes. I'll give you the formula. A cube minus b cube. Don't cram it. Look at what I'm going to do. It's a minus b that comes in here. Then I'll open the second one. Alright? What is a times a? A squared. What is a times b? Now that is ab, right? We are not foiling, okay? And then what is negative b times b? B squared. Positive here. The sign here has to change. I promise you, if you expand this, you are going to get a cube minus b cube. If you're doubting, let's expand. What is a times a cube? A squared? A cube. What will that give you? Minus a squared b, right? Plus ab squared. Is that fine? Now what do you have? Minus b times a squared would be what? Oh, sorry, I said the sign here should change. The sign here must change. If it's a negative here, it must be a positive here. So this becomes positive. Now, a squared times b is negative a squared b. I'm already doing it in my like terms. Minus b times that would give me what? Minus ab squared. Negative b times that will give me negative b cubed. Do you notice that this goes? And what do we have? A cube. Alright, so please take note of that. And if I were to have it as a cube plus b cube, it would be a plus b, a times a squared, a times b, ab, positive b squared, but the sign here should change. Beautiful. So, can I go back to x cubed minus 8 over 2 minus x? What will it be? X cubed minus 2 cubed, right? Over 2 minus x. This is still f of x. X minus 2. X times x, x squared. X times 2, 2x. It's a negative there. It becomes a positive. Negative 2 squared will become what? 4. Now, check. I notice that I have 2 minus x at the bottom. Oh, I can actually use sign change. Do you notice? I introduced a negative and switched it. So that if I expand negative times x, negative x, negative times negative 2, positive 2. Sign change. Do you know why I did that? This can cancel that. So what do I have? This is still f of x, my dear learners. We haven't derived yet. Negative x squared plus 2x plus 4. Negative x squared minus 2x minus 4. Now, what is f prime of x going to be? Negative 2x minus 2. I hope that makes sense. Negative 2x minus 2. Let's move on quickly for the next one. Okay, so we are done with those, and let's move on quickly to 8 points. Okay, let me do this so that I don't have to keep coming back. Now 8.3 and 8.4. 1 second, just want to cut those two parts out. Lovely. Okay. Determine the y dx if that 8.2.2. We are told the root of that equals to x plus 3. Now, before you derive, you must find what y is. Let's square both sides. Going back to thirds. Please, I'm begging you, do not distribute, you foil. Plus 6x plus 9. If I move the y over, what am I going to get? X over rather. 6 minus 1 would give me 5. Now, what is the y dx? 2x plus 5. Done there. 8.3. G of x is giving us that. All right. 8.3. Let's write it quick now. G of x is given as negative x plus 20. And f of x is given. Oh, they said that is a tangent. Oh, quickly understand it. My gradient is negative 8. That's one thing I must quickly know. And we are told that f of x is that. Beautiful. Now, I know that f prime of x equals to m. Let's derive that. What do we have? F prime of x, what would that be? 3x squared plus 2ax plus b. They said at x equals to 1. Once I put in my 1, then I know that the gradient is negative 8. So what do I have? 3 plus 2a plus b. Okay, my learners, once you see that you have two variables, then we need two equations. The question is, where are we going to get the second equation from? Remember, a hyperbola, check this. This hyperbola looks like this. And then we have a tangent. Do you know that they have the same value of x and y at that point? Because they both are on that function. All right? Okay, so I now know x to be what? Negative 1. Can I get my... Okay, I can get my y value there by saying that will give me what? 20 minus. That's y value as 12. But I want a and b. So what do I do? Let's go back. Instead of substituting into g of x, let's substitute into f of x. Y equals to what? X cubed. All right. Plus ax squared. I'm just writing that quickly. But let me write it out first. Bx plus 10. I know that my x is 1. But do you notice if I put that as 1, I'm going to have a problem with y. But like I said, I can get my y value from here. negative x plus 20. So what's my y value there? Y equals to negative 8, 1 plus 20. 20 minus 8 would give me 12. I can then come back and say, oh, the y value is 12 and the x is 1 because they both share the same point on the tangent. All right, no, this is b. X is 1 plus 10. Let's solve. 1 plus a plus b plus 10. All right, what is 1 plus 10? 11. Move that over to the other side. That will give us 1. So a plus b equals to 1. I now have my second what? Equation, which I can solve simultaneously. Let's do it the way you would have done. We can say that b equals to 1 minus a. Therefore, 2a, what is b? 1 minus a equals to negative 11. Make sense? 2a minus a would give me a. And if I move the positive 1 over, it becomes negative 12. Then I know that negative 12 plus b equals to 1. What is 1 plus 12? 13. So once you get two variables, understand that you must use a simultaneous what? Equation. Please understand the quick check on my videos. You would see what I call the big 5. The gradient is equal to the first derivative. That is the first key that is important when we do functions and calculus. All right, that is done. Let's go to question 9. In the diagram, we are given f of x, negative x cubed, blah, blah, blah. A, B, and C are the x-intercept of f. E is a turning point of f, and T is the turning point. T is a point of f, and G is a point on the x-axis, such that TG is perpendicular. Okay, TG is perpendicular. All right, don't forget, that gives me what? A vertical distance. D is the y-intercept. Calculate the coordinate of C. All right, check that. Calculate the coordinate of C if B is 1 and 0. The examiner is already given me a root of the equation. Now, a lot of us have different methods. We have synthetic, we have all of that. Okay, so already this is what I know. I know that f of 1 is equal to 0. If I use the synthetic, doesn't matter what method you use, okay, x cubed. So I have my a, I have my b, I have my c, and I have my d. Negative 1, 5, 8, and negative 12. We usually just drop this as negative 1. What do? We take that and multiply 1 times negative 1, and then you add. What is 5 minus 1? 4. You take that again, you multiply. It's all about multiplication. 1 times 4, 4. You take that, so you repeat it. Minus 12 plus 2, you must get a 0. Oh, now I know my equation. My A is negative 1, so it's negative x squared. My B, positive 4x. And my C, and this should be equal to what? 0. Let's solve. We can change the signs. Okay. What do we say? 6 and 2. So x is equal to 6, or, and you must just check your graph. Which one is C? It's the 6th one. It's far on the right hand side. I'm done. And if you want to use algebra method where you compare coefficients, do what you are comfortable with. But make sure you go into the exam with one method that you are completely comfortable and sure of. Determine the coordinate of E. Oh, sweet, sweet. This is the turning point. Coordinate of E. The turning point. All right, E, TP. What do we know? F prime of x. Good. Let's derive. Negative 3x squared plus 10x plus 8. Now what do? We equate this to 0. If you are not sure of how to factorize, please don't try to be a genius. Use your quadratic. But for me, I'm going to show you again. I'll multiply the 3 and the negative 8, which gives me what? Negative 24. Then let's factorize 24. What will give me 24? 12 and 2. Okay, minus there, because 2 minus, yeah, 2 minus 12 will give me negative 10. But I multiplied by 3, so I'm going to divide by what? 3. This must be a whole number. But I see 2 over 3 will not give me a whole number. I'm going to take that 3 here. Done. Then I'll bring it here. X minus 4, 3x plus 2. So it's either x equals to 4 or negative 2 over 3. Look at E. E is positive. Okay. What do we want? Determine the coordinate. So E, we're going to use this one. 4. What do? I throw my 4 back into the original equation. Anywhere I see x, I am going to put 4. Okay, let's use a calculator quickly for assurance of answer. Alright, so please look at where I put the negative. The negative is outside. It's my 4 that is cubed, right? Please don't put the negative inside. 5, what do I have? 4 squared plus 8 multiplied by what? 4 minus 12. What do we have? 36. Makes sense. Lovely. So I know my coordinate of E. X is 4 and Y is what? 36. For which values of X will F be concave up? Let's create another page for concavity. Concave up. So many ways. Check my videos. I spoke about 4 ways of getting your concave up there from the point of inflection. But don't let's be geniuses. Let's do something simple. F prime prime of x is greater than 0. Do we have f prime? Yes, we do. We said it's negative 3x squared plus 10x plus what? 8. Now, let's derive the second time. Negative 6x plus 10. Now, that should be what? Greater than 0. Guys, please watch this. I didn't change my inequality yet. Now, when I divide by negative, I am going to now change my inequality. Alright, and what's my answer? 10 over 6 would be what? 5 over 3. Please, very, very important. Calculate the length of OG if the tangent to the curve at T is parallel to the tangent to the curve at D. Ooh, let's go interpret. Calculate the length, alright, of OG. Let's go look at the graph. OG, okay, lovely. So we're looking for the x coordinate there. If the tangent to the curve at T is parallel to the tangent to the curve at D, the tangent to the curve at T is parallel to the tangent to the curve at D. Alright, what does that tell us? That what? Their gradients are what? Equal. And I said something earlier on. The first thing that comes to my mind is the first derivative is my gradient. Okay, we derived negative 3x squared plus 10x plus 8. But what do we know? At D. Oh, I see. What do we know at D? Let's go back. Maybe some of you did not see it. X is 0. So that gives us my gradient. Alright. So what is my M? Negative 3, 0 squared, plus 10, 0, plus 8. Gradient is 8. We're good. The gradient is 8. Come on. Gradient is 8. Oh, which means the gradient of the tangent at t is also equal to 8. The question is, we are looking for the length of OG, so we need the x value. All right. At t, what do we know? So 8. So f prime of x. Now, negative 3x squared plus 10x plus 8. Now I don't know my x value, but I know that that should be 8. So negative 3x squared plus 10x equals to 0. What's common? X. Negative 3x plus 10. Oh, x equals to 0, which was the first one we got. That's our D. Or negative 3x plus 10. So negative 3x. And what is x? 10 over what? 3. I hope that makes sense. So I now know that. Then I know the length of OG. Straight. 10 over 3 units. Why? I have my x value there. We are saying this point is 10 over 3. 3,333. Lovely, beautiful question. Find the value of m if y equals to mx plus c intersects f perpendicular at x equals to 5. Let's see. Find the m, we're looking for the gradient. Alright. If y equals to that, intersect f perpendicular at x equals to 5. Let's make sense of this. At x equals to 5. Where's our 5? 5 is somewhere, because we need to make sense out of it. What was our E? Our E is 4. What is our C? We got C. I want to just check something here. C is 6. Okay. Let's try to write those points. Okay, so that is 6. The examiner says we should find the value of m, the gradient. If y equals to mx plus c intersects f perpendicularly at x equals to 5. Guys, make sense of the question. At x equals to 5. Okay, let's put that there. Now, they said perpendicularly. It means there is a tangent here and then perpendicular. Oh, what do we know? If they are perpendicular, the product of their gradient should be equal to what? Negative 1. So all I need to do is to get the gradient of this line. Then I'm done. And this is the third time we're repeating this. Maybe it's a sign. The first derivative is equal to what? Gradient. And we know that that happens now at x equals to 5. So for emphasis sake, you should, we've repeated this 3 times, you should be able to get it. Negative 3x squared plus 10x. That's my first derivative. But m would be what? That. Let's put this in a calculator as we race to finish now. Negative 3 multiplied by 5 squared plus 10 multiplied by 5 plus 8. Negative 17. All right, this is the gradient. Now, the gradient of the line that intersects perpendicularly would therefore be what? We change the sign and reciprocate the number 1 over 17. Remember, both lines are perpendicular. The product of their gradient would be equal to negative what? 1. Okay, 9.2. Let's have 9.2 alone on this page. Looks like a freestanding question. Question on its own. Consider the graph f of x equals to, okay, that's out of place, negative x cubed minus 3x squared plus 4, and g of x, 23 over 9, that's a parabola. Now, determine the point where the graphs share a common tangent. Okay. Oh, if they share a common tangent, it means they have same gradient because the tangent is the same. And we know that first derivative, I don't know how many times we've spoken about this now, is equal to m. Alright, it therefore means that since they have the same gradient, f prime of x would be the same as g prime of x. Then we can solve. Sweet. What is f prime of x? Negative 3x squared minus 6x. Alright, yep, negative 3x squared minus 6x would be equal to 23 over 9 times 2 would give us 46 over 9x minus 19 over 3. To make life easy, let's multiply everything by 9. If you want to do it that way, multiply everything by 9. 9 times 3, negative 27x squared minus 54x. Now this is 46x, bring it over here. Okay, and then you have 19 times 3, 19 over 3 times 9, which is negative 57, but I'll bring it over. Okay, just simplify and bring that over. What do I have? Negative 27x. 54, 46 would give me that. And then let's solve. 27x squared plus 100x. Okay, these numbers look too big, so I'm going to use quadratic. Minus b plus or minus. Please show that. B squared minus 4 AC over what? 2a. We're looking for the value of x. Okay, come, let's see quickly. Grab a calculator. Minus b plus square root of 100 squared minus 4, please, bracket, very important, minus 57 over what? 2 times 27. Alright, we have a 0,5 and what? Negative 4,2. 0,5. Did we type everything well? Let's make sure. Yep. We have negative 27x squared plus 100. Okay, just make sure again. Not that I'm expecting anything else, but let's just make sure that we are on the same. Did I say negative 57? Okay, so we have what? Multiply, just to make sure. 54, negative 46x, and then plus 57, because 19 times 3, 57. Alright, so we have negative that. Negative, we change both positive to negative, and then we have that. Lovely. So minus b, minus 100 plus or minus b squared minus 4ac over that. What did we say our answer is? Negative 4,2 and what? 0,5. Negative 4,2 0,5. Here now we run to our application. A length of wire 4 meters long is cut into 2 pieces. One piece is bent into the shape of a square. Okay. We have a square there. Alright. and the other piece into the shape of a circle. Okay. Now remember, we're talking about the distance. We don't know exactly which one is it. Now, if the length of the wire, it's 4 meters, right? If the length of the wire is used to make the circle, it's x meters. Beautiful. So it means the circumference 2 pi r. Okay. Therefore, we are left with what? 4 minus x. Okay. 4 minus x. Now, each side of a square is the same. So this will be what? 4 minus x over 4. Okay. It's a square. Lovely. If the length of the is x, shows that the sum of the areas. Oh, great. The sum of the area of the square, sum of areas will be what? Area of square plus area of circle. Let's work it out quickly. What do we know? Length times breadth plus pi r squared. Here is my worry. We do not know our radius, but from here we know radius is what? X over what? 2 pi. So let's bring all of that in. What do we have here? 4 minus x over 4 into bracket. It's a square. Pi. What is our radius? X over 2 pi. X over 2 pi. Let's simplify. We must get that answer. The top is a foiling story. Okay. So 4 times 4 is 16. Minus 4x will give me 8x. We foil there. 4 times 4 is 16 there. Plus, what do we have? This pi would cancel that pi. What do we have? X squared over 2 times 2 is 4 pi. But that doesn't look anything like our answer. Here is where we need algebra. I told you earlier on, we can simply use diagonal denominator. Every time I have a fraction, I'll start from the left hand side. It's not cross multiplication, please. Now I see that I can multiply that. Let's see, will that work? Because I need to put everything that is x squared, and I need to just split this. Oh, wait. I need to split this. Okay. I don't think we need to do that. Let's split that. This is something as 16 over 16 minus 8x over 16 plus x squared over 16 plus x squared over 4 pi. These are like terms. Alright? They are like terms. What is common there? 1 over 16 plus 1 over 4 pi is common. Alright? Oh, it's what is left? X squared is common. Plus, no, it's minus. What is 8 divided by 16? 1 over 2x, which is x over 2, and 16 divided by 16. Yay! We got it. All right, we have already proven our 10.1. We've got that formula. Beautiful. What a lovely job. Now, 10.2. How should the wire be cut so that the sum of the areas of the circle and the square is a minimum? Please check. Number 1, I see they've given me the word minimum, which talks about derivative. But what? The sum of the areas. Wait, that is what we got here as f of x. Sweet. So what do we do? F of x we are given is 1 over 16, or which we proved earlier on, 4 pi x squared minus x over 2 plus 1. Now, minimum means we derive this first. What do we do? It's the x. So the 2, 1 over 16 plus 1 over 4 pi. I have x minus, what is this? Half. And we know that at minimum, f prime of x must be equal to what? 0. Oh, great. So we just equate that to 0. 2, 1 over 16 plus 1 over 4 pi, x minus half equals to 0. Let's move the half over. 1 over 16 plus 1 over 4 pi x equals to what? Half. Okay, we can get a value here and just divide, right? We can get the whole value here and say half divided by that. So let's get a calculator and say on the left hand side I have 2 into bracket 1 over what? 16. Where is it? 1 over 16 plus 1 over 4 pi. Okay, that would give us a particular value. And then we say half divided by that. Okay, 0.5 divided by that. 1.76. Sweet. X is 1.76. So how should the wire be cut? All right. The square should be cut with, the circle. Which one is the circle? The circle is x is 1.76. Okay, so the circle circumference 1.76. While the square will then be what? 4 minus 1.76, which will be what? 4 there. And then that should give us a 9 and 2.24 meters. So this is how it should be cut. Great. And that's how we work things out. I hope it makes sense. The probability that it will snow on the Drakensberg Mountains in June is 5%. When it snows on the mountains, the probability that the minimum temperature in the central South Africa will drop below 0 is 72. If it does not snow, so already I have options. I know I'm drawing a tree diagram. If it does not snow on the mountain, the probability that the minimum temperature will drop below 0 is 35. Calculate the probability that, let's go back and read. It's either it snows or not snow. You can do that, not snow. The probability that it will snow is 5%. It automatically means this is 95%. Okay. When it snows on the mountain, the probability that the minimum temperature in central South Africa will drop below 0 degrees Celsius. Okay, so it's either below 0 degree or above 0 degree. Let's check. That it will drop below when it snows is 72%. You know what that means? Minus 100. That gives me 28%. Again, less than 0 degrees, greater than 0 degrees. What do we have? If it does not snow on the mountains, not snow, the probability that the minimum temperature will drop below is 35%. Automatically, this is what? 65%. So it is snow and below 0, snow and above 0, not snow. Let's just use, we don't have to use English. Snow and what? Less than 0, snow greater than 0, not snow less than 0, not snow greater than 0. Calculate the probability that in Central Africa it will not drop below. They have emphasized the word not, drop, which means greater than 0. So probability of greater than 0 will be probability of snow and greater than 0 plus probability of not slow but still greater than what? 0. Okay, S, and so we are looking at where it is greater than 0. We just follow. It is 5 and 28, and then that leads us here, and this one 95. We just multiply 5% times 28% plus 95% times 65%, and we are done with this question. All right, so create a bracket. 5% times 28% plus 95% times 65%. 0.63. We're done there. All right, so just take your time, get the marks that you need to get, and enjoy maths. The last part of this entire paper. Non-clear who is in grade 12, who is a grade 12 learner, has 8 textbooks from 8 different subjects. 12, okay, yeah. Drama. Wants to arrange them on a shelf. In how many ways can the textbooks be arranged? Since they are different textbooks and they cannot be replaced or repeated, 8 factorial. Please don't just write that. Get your calculator and do the factorial. And this is 40320. Lovely. If the math textbooks and accounting books must be at the end of each of the shelf, what is the probability that the history textbook and okay, let's take it slowly. And this is what I like to do. All right, since there are 8, I'd like to create that 1, 2, 3, 4, 5, 6, 7. Okay, if the math textbook and the accounting textbook must be at each end, all right. Now you see we are creating math and accounting. It could also be accounting and math. We'll deal with that. All right. What is the probability that the history textbook and the tourism textbook are not next to each other? This is very beautiful. We are going to calculate if they are next and then subtract from total. First, math is 1, accounting is 1, right? And that is fixed. Now we do not want the history textbook and tourism. We don't want them together. So let's do it this way. What is the probability of having them together? Okay, history and what? Tourism. This is what we do. We take a block. Check this. We block that. Okay, we block that, and we have 1, 2, 3, 4. So in total, what do we have? We have 1, 2, 3, 4, 5, 1, and 1. Okay, what would that be? That is history and together. 1 times, we have 1, 2, 3, 4, 5 factorial. But now the history, and this could be history, tourism, history, which is times 2 factorial times 1. This is the books being together. The books are being together. What would this give us? 5 factorial times 2 factorial. 5 factorial times 2 factorial. 240. Okay. So we're saying we're keeping the math there, accounting there. All right. But remember, we can switch the math and the accounting. So times 2. So this gives us 480. This is if we keep the math and the accounting and the history and tourism books together. But we don't want them to be together. So history and tourism not together will be total minus together. But we are still keeping our maths and accounting constant. All right, so which will be maths. All right, what is my total? I have 1, 2, 3, 4, 5, 6 are moving around. Accounting. But I can switch my maths and an accounting. Minus 480. I hope that makes sense. Together, but keep in mind you're keeping your maths and your accounting stable, and you can switch them. So this is 6 factorial times 2. 6 factorial Nope. 6 factorial, all right, times 2 minus 480, 960. So these are 960 ways. But what is the examiner saying? Probability. So we now look for probability, which will be what? 960 over the entire total. The entire total, which is what we got, sample space, and that will be let me get a calculator quickly. 960 over 40320. No, what am I doing? 960 over 40320. All right, probability must always be less than 1. Great. Okay. Oh, done with the paper. Guys, we appreciate your feedback. Please leave us a review. Just scan that and leave a review first on this video on YouTube. Give us a comment, give us a 5-star, give us a like, share the video, comment on the video, forward it to someone. Scan that and leave us some review on Google. We will appreciate that. This is Crazy Physics. This is Bishop, and this is me signing out and wishing you all the best as you write your maths paper 1. Good luck. Goodbye.